is we're supposed to be multiplying out the brackets of 2x minus y minus 3 brackets y minus x. Yeah. The way to go about this is to multiply these brackets. So 2 times x is 2x. 2 times minus y is minus 2y. So that's that bracket multiplied out. Yeah. Then minus 3 times y minus y. Yeah. And minus 3 times minus x is minus 3 times minus x plus 3x. Yeah, remember what we said, this sign here goes with that number. If you deal with that separately, what you've got to do is take all of the multiplying out of that 3y plus 3x away from all of that. That's a more tricky way to do it. Because now we can gather the like terms. So we've got 2x here and 3x there is y minus 2. So we've got minus 2y, take away another 3y, minus 5y, and then we've got a 5 term that we can factorise. Alright? So being careful with those laws of precedence and dealing with that half separately from that half, starting from the left. Alright? Does that clear up those that were having a little bit of trouble with number 2? Yeah. Question 3. 2 brackets p plus 3q minus r minus 4 r plus q plus 2p, close the brackets, plus p. So have we started on that one, Regan? Okay. Anyone who's started it and struggled, did you not even try? You didn't even. What did you start doing then, Regan? Yeah, so that's a good start. 2 times p is 2p, which is 2 times 3, yeah, plus 6q. Yeah, and then you done, which is minus 2r, yeah. Alright. Then what did you try? Yeah, so that is minus 4r minus 4q. 4 times 2 is minus 8p you had. Yeah. I've done minus 4 times 2 is minus 8. Yeah, p. And then we got a single p on the end. Yeah. And then that's about collecting all the like terms together. So where's that? Yeah, because it's minus 4. Oh, sorry. Does it? Let's have a look. The minus q. Beg your pardon. So this is in here. It's minus q. That makes, what does that make here? Minus 4 times minus q plus 4q. Right? Well spotted. So what we can do now is collect together like terms. So we've got 2p and minus 8p plus p. So 2p minus 8p is minus 6p, plus p is minus 5p. We've done that term, we've done that term, we've done that term. What about the q's? 6q plus another 4q plus 10q. Yeah, and we've done that term, and we've got minus 2r minus 4r comes to minus 6r. And there's nothing in there that will factorise, because there's no point in taking PQ and now we've not got nothing there we can factorise at all, because these are not divisible by any particular number. Alright? Happy with that now? Yeah? Macaulay. Forget. Practice. That'll drum it in. Yeah? Alright? Alright? You'd be surprised how much difference half an hour, even half an hour a day, or every other day will make. Just finding some problems and having a go at them. Then have a go at the things that you're struggling with. Don't practice the things that you can do. Alright? Okay, so there's plenty more there that you can have a go at. Please, something you really struggle with, come back with it next week. Point it out. We can always try and go through it. I've only got a finite amount of time. We've got quite a few things to cover, as you can well imagine. Alright, but I'll try not to leave anything behind, because that just leaves problems to face. So, done that. Laws of indices. I've got them here somewhere. Still on the other. Here we go. Right. Laws of indices. When numbers raised to a power have the same base, so in this example, x, to be able to apply the laws of indices, you must have the same base. Raised to a power, yeah, the laws of indices can be used to simplify. And this is a very, very important topic in terms of being able to deal with the calculus that we eventually do in Learning Outcome 4. Okay? So in other places as well, but particularly there, laws of indices and being able to change the way we write an expression so that we can apply calculus will be really important. So, the first law we've already come across this morning, the law of multiplication. When two numbers with indices in the same base are multiplied together, we can simplify by adding the indices. So x to the a times x to the b, we can write as x to the a plus b. So in this example here, and I do recommend until you get used to it, you actually write it out, that's equal to x to the power of 6 plus 3 equals x to the 9. Yep. Alright, so first law of indices, if we multiply together, we add the indices. Again, being careful where negative and positive signs together are involved. Alright? Second law, that of division. So if we've got x to the a divided by x to the b, we can write that as x to the power of a minus b. So in this example, we can write this as x to the 7 minus 4, which is x to the 3. Yeah, we subtract the index. It's important to get these two numbers the right way round. We must subtract the index of the denominator from the index of the numerator and not the other way round. Okay? Everybody happy with those two? And we've already come across those anyway. Right. Third law. Numbers raised to a power and then raised, all of that is raised to another power. So if we've got x to the a in brackets, and then that bracketed term is raised to the power of b, the result of that is x to the a times b. So in this example here, it is x to the power of 2 times minus 3. The result of that being 2 times minus 3 is minus 6. Misprint in your handouts, that is the fourth law on roots. Okay. So all happy with numbers raised to a power, then raised to another power. Fourth law is roots. So if we've got x to the power of a divided by b is equal to the bth root of x to the power of a. Okay. So what we're usually interested in being able to go from that form to that form or vice versa. In calculus, you won't be able to use the root in that form. You'll need to write it in indices form. So you'll need to go the other way. If we take x to the 5 divided by 2, first of all, x squared, it's worth remembering this, can be written as x to the half. Yeah? So if you think of it as, sorry, not x squared, square root of x. Now, when we write the square root, we don't bother to put the little 2 in there, do we? We only do that if that's the third or fourth or fifth root, right? But if you think that number that's there is the denominator, and the power here is the numerator, we don't bother to write x to the 1 either. We just leave the 1 off. But it's what it is. Any number to the power 1 is that number. So it helps you with ones like this to say this is going to be the square root x to the 5. The numerator goes there, the denominator goes there. And you actually wouldn't write that like that, you just say that's the square root of x to the 5. We don't bother by convention writing that too. Okay, and when you get square roots, when you get roots in calculus, you'll need to be able to go from that form back to this to be able to do the work. Alright? Happy with that? As happy as you can be? Alright. Reciprocals. X to the minus a could be written as 1 over x to the a. These numbers I got out here somewhere, 5th, 6th, 7th. Sorry about that. It's not that. You're not expected to remember what the number of the law is, just expected to be able to use them all. Okay? So what we're saying is, if we have a number to a negative power, we can write it as 1 over a number to the positive power, and vice versa. Effectively, what happens here is, if that goes from the top to the bottom, it changes sign, or vice versa. So we can write x to the minus 4 as 1 over x to the 4. Yep. 1 over x to the 5 can be written as x to the minus 5. And if you think about this one, the way it could be written as x to the minus 4 over 1. Yeah? That. Alright? And what can we write 1 as in terms of x? How can I write x and the answer be, what power do I have to write x to make the answer to it 1? X to the 0. Now apply the second law of indices. Sorry, x to the... Hang on, I'm losing myself now. I'm trying to prove something. I can write that as that, yeah? And then it's x to the minus 4 is, goes from the top to the bottom, the sign of the index changes. Yeah, again, we'll need to be able to write something in that form, move it to that form, to be able to do calculus again. Alright? And then what we've got is this power of 1 thing, where x to the power of 1 is equal to x. What we're saying is any number to the power of 1 is equal to itself. So a to the 1 equals a. It's useful to be able to remember that we can write it as a to the 1. That's the point I'm making here. Yeah, and then the 7th, any number to the power of 0 is equal to 1. So z to the 0, 1. X to the 0, 1, and so on. Equally, if we want to, we can write a variable to the power of 0 so that it equals 1. This is what I was looking for. 1 over x to the a, 0 over x to the a, making that x. It proves that law of change from top to bottom of the sign. Okay? Yep. I knew that was on there somewhere. All happy with that. So, there's some laws of indices practice. Yeah, simplify and evaluate. So when it says evaluate, what it means is simplify that term and then set x equal to half, y equal to 2 and z is equal to 3 to get a numerical answer. Should we do that first one together? Yeah. So what have we got? We've got x squared y cubed z in brackets times x cubed y z squared. Not missed anything out, not put any indices wrong. And we've been given some values to evaluate when x is equal to a half, y is equal to 2, and z is equal to 3. The first thing we've got to do is simplify that term. And I realise that you can put these values in and calculate an answer now, but how do we simplify that term? What we've got to do is multiply this bracket. Process from earlier. X squared times x cubed. So the law of indices says x to the 5, yeah, 2 plus 3, x squared times y, can we do that? The laws of indices? No. Yep. What can we do? There it is. Yep. No, because they're all multiplication. There's no addition in there, is there? Or subtraction. So you just pick the like terms and multiply them together. Because they're all multiplied. No plus or minus in there. Yeah. Then what we do is we put these numbers in for x and y. So we put a half to the power of 5 times 2 to the power of 4 times 3 to the power of 3. And then we put it in our calculator and get the answer, hopefully, 13 and a half. How are you putting it in the calculator? I'd put that as a fraction inside brackets and then raise the brackets to power. So you've got a fraction button on your calculator. Y is the answer to number 2 plus or minus 4.5. Anyone know? Well, that's correct that the answer is plus or minus 4.5. My question, and I've suspected that I wouldn't get the answer, is why is it down as plus or minus 4.5? And I think quite important actually that we go through that one too. So question 2, next page. It is simplify a to the 3 over 2 b c to the minus 3, close that bracket, I to the half b c to the minus a half c, close the brackets. Okay, we've got to evaluate that when a is equal to 3, b is equal to 4, c is equal to 5. So how can we bring the a terms together? What law of indices we apply to the a terms? Yeah, so we've got, I'm going to write this out longhand, we've got a to the 3 over 2 plus a half. Because we've got 2 indices there that are multiplied together, so we can add them. So that's equal to 3 halves plus a half with 4 halves, or what is it actually? With 4 halves. 2. So the a term is 8. We've got b here. So we've got a b in there. So what's that? B to the 1 times b to the 1, b squared. Yeah. C term. We've got c to the minus 3 times c to the minus a half plus 1. What does that result in? C to the 3 hang on, yeah, c to the minus 3, the minus 3 plus a half plus minus a half minus 3.5 plus 1 isn't plus plus 2.5. That's minus 2. He's got minus 2. Try to see where he's got that.